Hello, everyone. I'm Dan Gay, Chief Marketing Officer of BlockCerts Blockchain, and thank you. We've been here all week. This is day 5 at the Singapore Fintech Festival, and we've had some amazing speakers, and we're going to continue that here today with an individual that is going to take us beyond the clouds, and into actually space. It's a new frontier that only few have been able to harness and take advantage of in the past. And today you'll actually hear about the opportunities for many businesses to get involved with all of the opportunities that renting a satellite and the SaaS world can have for businesses. So with that, let me get started and announce our special guest here today, this morning, or wherever you're coming from around the world. And this morning we have Dennis with us, Dennis Silent, who's the Chief Executive Officer of Exodus Orbitals. And great to see you, Dennis.
Hello, everyone. Nice to meet everyone again here. And yes, I'd love to start telling my story about our company and a little bit about myself. So I'm a software developer. I was a software developer, and I spent quite a number of years working in information technology industry. However, my true passion was space exploration and space, and this is why my second degree is in astronautics and space engineering, which I did only a couple of years ago. And during my time in my master's degree, I founded Exodus Orbitals, where I united space exploration and software development.
It's just an amazing story, and even more amazing when you find out more about this. And so let me introduce Tim Vasco, who's our Chief Executive Officer of BlockCerts Blockchain. Hello there, Tim.
Hey, Dan. We're going to space today. This is exciting, and there's a really interesting business here that I think you're going to learn about and understand a lot more after you hear from Dennis and get an idea of how space satellites can be used on the cloud, or to get beyond the cloud, as you said, Dan.
Absolutely. And then we have Tiffany Johnson, who has been coordinating a lot of the activities at the Singapore FinTech Festival and is our Chief of Staff. And good morning to you, or good afternoon, Tiffany.
Good morning, good afternoon. Hi, Dennis.
Yeah. Thanks for all the hard work, Tiffany.
Yeah, let's get it started.
I've got my apps ready.
So
to sign up.
Get going, and here we go. We're going to space. So Dennis, tell us a little bit about Exodus Orbitals and satellites for rent, and how this all works.
Well, the core concept is quite simple. Space is an extremely capital-intensive industry, and if you want your own satellite and you want to do anything in space-related activity, many people have a lot of good ideas, but they just don't have that amount of funding on hand to participate in space exploration or space industry activities themselves. So our idea is to basically build and launch a satellite that we then can provide for other people to use on an as-needed, pay-as-you-go basis. And how are they going to use it? Well, it's simple. All the satellites nowadays have sufficiently capable onboard computers that can run any kind of software. And what we are going to build is basically a satellite as a service, a virtual satellite that will be accessible to the people on the ground in a way similar that cloud computing works on Earth at this moment. We'll focus on building the infrastructure, and then we'll provide all the tools and all the accessibility to all the software developers, space enthusiasts, and small and medium companies in the world that would be able to develop their own space applications and then deploy it on our platform. This concept has a lot of sense if you start thinking about it. Satellite is essentially a platform with instruments, with computers, which absolutely can be rented out between multiple customers. And there's quite a number of different applications in space that you can do that you cannot do just using terrestrial-based means. Here's a way how we're going to implement the success. Again, very similar to what web developers use nowadays, or mobile developers. They will get access to our tools, to our pipeline, to all the bits and pieces on the ground and in space. They will write the code that then will be able to be run on the satellite in space, effectively giving them full control of a real spacecraft in Earth orbit and beyond. A bit more on what kind of tools and instruments they will get. The imager, the onboard computer, and optionally a software-defined radio, which in all these cases can be reconfigured for multiple different missions. And this is the core hardware capabilities that we'll provide to our clients, to the software developers. And in this manner, they will be able to create a number of applications using this hardware.
Well, let's talk about, that's fascinating. So let's talk a little bit about that and break it down. So basically what you've got is you've got this ability to put applications up into space. And let's talk about what that means. First of all, how did you come up with this? And tell us how you got a satellite up in space. I understand you're working with the European Space Agency. Maybe you can talk a little bit about that.
Yes, so a bit of backstory on how I came up with this idea. Well, it was not like a lightning strike moment. What I did back in 2018, I reviewed every single upcoming nanosatellite CubeSat mission between years 2019 and 2023, and tried to find any kind of concept that wasn't in this list. So that was an 80-page long document, which I compiled from the open sources, reviewed every single one of this mission together with the help of my teammates. And then that idea popped into my mind. Well, that satellite for Ant, this seems not to be on this list. So let's go for this one.
Okay.
So that answers the question how I came up with an idea.
And then you contacted the European Space Agency, or how did that happen?
It was a bit more interesting, so more interesting part of the story. So as we started to build and define this mission, and we're about to close the design of the first hour mission, I decided to review that list again to see if I missed anything. And then I found that mission, the European Space Agency mission on the list, I missed it the first time. But when I read the description, I realized it was exactly the same concept as we are building. So initially I got upset, so it seems to be like the same idea. But then I realized this opens an opportunity for cooperation. So after a few emails exchanged between us and the ESA team, we didn't need to explain this concept to each other. Everything went smoothly, and we got invited to participate in the ESA mission, which was supposed to launch in 2019, and it did. So we are one of the clients for the ESA, with ESA being the satellite owner, which they rent out to their customers, or in this case, because as a space agency, they give it out for free to the companies that are part of the European Space Agency country list. That's how we came up to join this mission, the ESA one. And this mission is in orbit and it's been in mission in progress. And based on the results on this mission, we plan to build and launch our own satellite and make a commercial service. That will happen in 2021.
So let's talk a little bit about the demographics and the people who actually are going to use this technology initially, that need to build space apps, want to build space apps, and why they're there, why this makes sense.
All right, so we're going from small to big, and our first clients, which we already have, are small companies, single individuals that are interested in space exploration and have software development skills, and a couple of universities which will be giving them capability to their students and researchers to deploy their code on our satellite. And then we're also going after the big guys, after the companies that are interested in deploying something in space but don't want to develop their own satellite from scratch. Our primary advantages are costs. First, if you need a satellite for just one orbit, you only pay for one orbit. You don't need to go into the full SpaceX scale of project. And the second cost is flexibility. Flexibility is important. You need a satellite, application working over the coast of Ireland, and you get just that. You don't need to operate your satellite anywhere else. We are taking care of all the operational needs. Flexibility, you get choice of instruments. With a constellation of satellites, you can jump between multiple hardware options, using only the ones you need and paying for only the ones you need. Well, here's my explanation.
So that gives you the ability to essentially commercialize space and create for a few $100s what would otherwise cost hundreds of thousands of dollars.
Exactly.
And I think what's fascinating to me when we first started talking about this was the applicability of like the projects that need something like this. So I think people we think about all the things we do on our phones, maybe Google Maps and things like that. But we don't think about is how dynamic the Earth actually is and what we can't see from even, airplanes or helicopters or things like that, and how space really expands the ability to observe the Earth. So maybe talk a little bit about what are the business use cases? Like, why would there be a need for space apps? Just let's throw out a couple so people understand what we're going to use this for.
Yes, I'll give a couple of my most favorite examples. One very good application for this kind of service is identifying and tracking shipping containers that have been washed overboard from the container ships. Those containers have a very distinct shape. They're nothing like natural shapes in the ocean. Also, they present a huge navigational hazard and big losses for the ships going along the same similar traffic lines. So if you can write a space app that basically identify those container shapes floating in the ocean, attach GPS coordinates, latitude, longitude, and then download the list of these free floating containers to the ground and provide a service to all the maritime merchants. These containers floating in this area, please avoid. If there's also opportunity to recover them and recover some of the good lost, this is immediate economic effect that can be harvested by got by everyone in the world pretty much.
And not only economic effect, think about the different real impacts that this has. So we recently saw this oil spill in Mauritius that was very devastating. So a tanker hits one of these things and it breaks up in the ocean. We've got a catastrophe that costs millions and tens of millions of dollars. Another element of that, just one example that you used, is insurance. So by having the merchant ships subscribe to this service, guess what? Somebody pays all those damages costs, and it's usually insurance companies, right? So how much do premiums go down and costs go down? So we've got social impact, environmental impact, safety, life. People that go down on sinking ships die. And so we save lives. And that's just one really good example of something you couldn't possibly do with airplanes and helicopters, especially out in the middle of the ocean where in some cases you can't even get a helicopter. There are parts of the ocean. I don't know if people know this. There are parts of the ocean still where if a helicopter or one of these observational units goes, it's a they can't get back. They can't get back to Earth, right?
It's just, thousands of kilometers from any nearby land.
Yeah, exactly.
Another good application, this one on the ground, is crop yield prediction. So it's a real application that other people have been working specifically in one of the ESAR programs. You can basically, from a satellite photo, you can estimate the quality of your crop fields, the expected yield of the crop, and you don't need to download the full image. Using specific spectral bands, you just look at the wheat or the beans, and identify the maturity stage, the number of the sick plants, and so on. And what's important, this service, the satellite can cover entire globe, but the limitation is you cannot just download all the raw images nonstop like you can do over internet. Basically, you can expect only 1% of your imagery data to be available for download. But the satellite application can run on the satellite non-stop 24/7, and you can process this data, extract the insights, again, attach the metadata, which is basically the coordinates and text description, and download only these important bits to the ground. This is a huge help to all the farmers of the world. They can subscribe to that application and get their data insights at fraction of the cost that was previously possible. Not every farmer,
Right.
even in the developed world, can afford their own satellite. With our platform, they will be able to do so.
Yeah, because you can sell it for dollars as opposed to thousands of dollars, right?
Exactly.
And another one that I think is really important is things like natural damage or natural disasters. When we think about where Dan lives is in Denver, Colorado, there's hailstorms every few years that cost insurance companies billions of dollars. Tornado damage, flooding, things like that. We know what hurricane damage looks like. And with a satellite, you can really fly over these zones, not only to help people, but also to help insurance companies and recovery companies and so forth get in there and see exactly what's going on or what the damage is and what needs to be repaired and assess the costs almost immediately, can't you?
Exactly. There's one other good application that, again, is already developed by the researchers of the world, is take California fires. It's much easier to prevent a fire than, fight it after it started. So one of the applications is evaluate the state of the forest canopies and see other critically dry spots and, cover them with fire retardant before the fire starts, and saves like literally billions of dollars of damages. It's called natural disaster prediction. Again, requires the satellite going over the area, taking a photo, but not just downloading it. An application has to process it on board and extract those critical bits of data and download on the ground and give the local fire department like notification, hey, like this 75% probability of that patch in this GPS spot to, at risk of, starting a fire.
So we're at the Singapore Fintech Festival, and one of the things that we're talking a lot about is insurance, and a big market is InsurTech, right? And insurance technology that is literally able to grab this analytical insight as well as live data and prevent losses. So real-time insurance, like preventive insurance, as opposed to post-damage insurance, is really a huge advancement for underwriting and taking care of these kinds of things in advance, right?
Exactly.
Or saving firemen's lives in California to rescue them because they're caught in the middle of the fire trying to put it out, and you need satellite to go in and rescue them. So I'm in California, that's why, it's huge.
Yeah. So let's talk about like this total addressable market and have a quick look about what we're talking about: Earth observation and communications. And what do you estimate the market to be?
Well, at this point, like our initial market will be in CubeSats, small satellites that are size of like shoebox. But this market is the fastest growing market segment of the entire satellite industry. Its current size is about 2 billion and predicted to go multiple times of that in the next 5 to 10 years. Literally, if you go on the website called nanosats.eu, you can see the curve of the current and predicted small satellites being launched. Literally, like goes exponential, expected to be tens of thousands. And literally 10 years ago, there was like a single satellites per year. Now it is in hundreds.
Well, you can certainly see why that would give you a market edge and this opportunity to expand these kinds of applications throughout industries and developers. So tell us a little bit about what your actual solutions, like, let's summarize this with what is that unique opportunity that Exodus has here for this giant and rapidly growing market?
Our edge is that we are not a space company. We are a software company in space. So what we are going to build is development platform for the developers, small and large, very similar to iOS App Store model or Google Play market. Having that platform, as soon as the first developer appears, give us that users, the confidence that users will stick to this platform, and it is going to be like accumulate a critical mass very fast. There is no need to have your own rocket. There is no need to have your own satellite. All you need is a credit card and a laptop. This is the model of growth that was successful for the internet, for the web applications. This is the model of growth that was successful for mobile applications, and this is the model of growth that will be successful for space applications.
So very similar to what cloud computing did a decade ago or more now.
Pretty much. I was living throughout the history of the cloud computing development, of the mobile development, web development. I know ins and out of this market segment very, very well, and we are going to take the same model to space, and it's already feasible to do it on the technical side. So there are no hard barriers to push through on the technology side. It already works.
So let's just summarize with where the history is at. So in 2019, you started out with ESA.
Exactly.
And 2020, you have perfected the software and hardware combination model. Let me just ask, are you in space right now?
We are in space right now, yes. So work in progress in terms of our platform, but it is ready for 2021 commercial launch.
And what's NOVA?
NOVA is what our own satellite will be, the name of our own mission. ESA is, or OPSAT is the name of the ESA mission, and NOVA is the name of the Exodus Orbitals mission.
So you're going to space, you're in space, you've already done all this, and it's a great opportunity to start understanding what cloud in space or means. Actually, what was it I just heard in our region? This is, I don't know, tell me, I'm curious about this. I just read this last night. So there is a electromagnetic cloud up in space that the BC Hydro is worried about is going to knock out or disrupt power, and we could lose power all over our British Columbia here. Are you familiar?
Yeah, I'm familiar. It's kind of natural phenomena, which is a danger to satellites in space as well, but it is a known danger. There are means to mitigate this the effects of this kind of event. It's basically like a solar flare that is aimed at Earth. People need to shut down certain parts of electrical grid, or even certain parts of the satellite hardware in order to minimize the potential impacts. But I'm pretty sure you'll be fine.
Well, space certainly has a huge, aura about it, a huge opportunity. It is the new universe. I'm excited to work with you on some applications, Dennis, on how we're going to, authenticate all this. We don't have time to go into cryptography and security and all that kind of stuff that we've talked about. But what we're going to do over the next several weeks and leading into our launch, literally launch part 2, mission 2 in Hong Kong, is be bringing out very specific examples like you've heard today from Dennis about what Exodus Orbitals is. And in the meantime, we'd like you to be able to contact us. Exodus Orbitals is on Fusion Funder. We're bringing up all of the websites and information, and everybody that is interested in learning more about how you can become part of going to space with technology and opportunity. We encourage you to register and follow us as we get this mission started.
And space really is the new frontier, and thankfully, Exodus Orbitals is allowing that to come to fruition for not just the largest of companies, but for any company. And that's what's exciting. You talked about a number of applications. I can think of golf course maintenance, or governments or cities that are thinking about their growth and managing growth, all kinds of things that we can't even imagine today, but with this community, those applications will just expand, and the network effect will help and happen. So exciting.
Absolutely. We all watched the launch of the Starship prototype yesterday, and it was an amazing thing just to watch it. Now imagine how it will feel to have your own little Starship project going on actually in space. It's hard to compare, hard to find anything else like this.
Yeah,
right,
very exciting.
It's all a chance to be astronauts and do that. So with that, Dennis, this is a really cool project. It's important. It's valuable. There's certainly trillions and trillions of dollars that depend on this kind of technology. So I can't believe how far you've come and how fortunate we feel to be part of this. So let's go ahead and wrap up now. And as I always like to say to everybody, stay safe, stay healthy, and stay digital in space. That's where we're headed.
Yeah.
Okay. Thank you very much.
That's great. Thanks for joining us, Dennis.
Thanks,
Yes.
Dennis.